Okay, in this video we're just going to make a quick little fun program in which we have a terminal window that prints out a box, and then we're going to have a little character inside that box in the middle, and we're going to issue commands, and that character is going to move either up, to the right, down, or to the left by a certain number of spaces that we specify. So it's just a little toy program to practice your programming. So need a new file. We'll call this boxmove.py. And what are the things we're going to need? We're going to need to know how many rows and how many columns we want for our box. So rows, we'll say that is 23, and then the number, actually, no, that's too big. We need 13 for the rows. And then columns, because the columns are smaller than each one of these characters is taller than it is wide, so there'll be more columns, so we'll make that 23. Okay, and so basically what we have to do here is iterate through a nested for loop for row in range rows, and then for column in range columns. And we will say if row is equal to 0, so that would mean we're in this first row, we want to print out the horizontal bar. Or if row is equal to, I say greater than or equal to rows. Right? Then in that case, we are going to print the pipe. So that's if the row is the first row, then that's the top of our box, and if it's the last row, then it's the bottom of our box. So it's not greater than or equal to rows. It's gonna equal rows minus 1. Yeah. Right, because the range function is never going to equal the last item. Right. This is our ending point in the range function, which is 13 here, so it'll never, row will never be 13, it will at most be 1 minus 13, so we say 13 minus 1, and that will be the last item, so that'll be the last row in our box. So either way, we're going to print the hyphen, and we need to print the end character. We're not going to print a new line after every single one of these prints. Okay, this print statement, we want to print one character, but we don't necessarily want a new line character, so there's a special keyword argument for the print function in Python3 called end, and it specifies what ending character you want to print after you print out the thing that you're trying to print here. So that first argument. By default, the end character is the new line. So if you don't provide this argument just like that, it's the same as providing this. Okay, but we don't want that new line character. We're going to have no ending, so we're just going to print this one character and not print anything else. All right, so that should print out the top of our box, and then elif column equals 0 or column equals columns minus 1. Then sort of the same situation, we're going to print out a pipe, and that's it. And then otherwise, to fill in the rest of the box, we need some other character, and that's just going to be the empty space. So we'll print out one empty space. Okay, and so this for loop is essentially filling out one row of information, and then once we iterate to the next loop in the next iteration of this loop, that's the second row. Okay, so each one of these is filling out a row, right? And each one of these loops moves down, right? So what we need to do here is, after we've filled out an entire row, which is essentially what this loop does, we have to add a new line character. Or in this case, we can just print. Printing like this, because the ending character is a new line, that essentially just adds a new line. Okay, so this is going to fill out one row, and then that print is going to create a new line. Then this will fill out the second row, the print will print a new line, then the third row, etc. All right, so we can run this real quick. Python3 box move, and we have a nice box here. So what do we have left to do? Well, we need to have a character, and that character has to have a position, right? So we have the position, what row is our character in, and we'll start it out in the middle. We'll say it's however many rows we have, and then we'll integer divide by 2. So integer divide by 2 just divides by 2 and then truncates any decimal value that's left over. All right, so and then position C is going to equal columns integer divide by 2. And so the only difference here now, so these two variables now keep track of the position of our character. So it's going to be right here in the middle. And if we change the values here, whenever we print this out, we're going to get a different positional location of our character. All right, so here, first we have to make this one first because we always want to make sure our character prints on top of any borders or anything like that. Okay, so that's going to make this an elif statement, and this one will be the if statement. So if row, so remember row is this item in this for loop, right? So this is essentially row and column combined. Each time through is going to be one position of some character, right? It could be there, it could be here, right? At some point, both row and column are going to be the same as our position of our character, row-wise, and the position of our character column-wise, right? So if row is equal to position R and column is equal to position C, then we know row and column are now talking about describing that one single character spot where our cursor, our character that we're going to draw is supposed to be positioned. So if that's true, then we add a print statement and we print out our special character, which we're going to use the asterisk for. And just like all the other ones, we have the ending of the empty string. Okay, so we can run this and we see the character prints right in the middle. Alright, so what next? Well, we want to be able to move this character. So if we're going to be moving something, then when we print out the board, we have to be able to print out the board multiple times. Okay, so define print box, and all of this stuff we will indent. This will be print box. Okay, so all we did was the part where we actually print the box, we just indented it and put it into a function, and then down here we called the function one time. So nothing should change in the output. Okay, so that looks good. What else do we need? Well, we need to be able to move this thing, right? So let's make a function called move, and it's going to take a direction and a number of spaces that you might want to move from the current location. So this count is going to be relative to the current location. So here, if I say the character up and then 2, it's going to move up 2 from my current location. All right. So in order to do this, what we want to do is we want to reference. Eventually, this move function is going to have to modify these two values, right? The values stored in these two variables. Now, these two variables are global variables. Okay, so by default, that's not allowed in Python. You have to use the global keyword and say, very specifically say, I'm going to modify this global variable, and we're going to modify this other one too, position C. All right. So that's going to allow us to modify this, and when we get done with this function, these two variables will hold new numbers, which means when we call print, this part will be a different row and different column where we actually print out our asterisk. All right, so to do this, first thing we want to do is we may not be changing these at all, okay? Because if for example, if the user types in something that's too big outside the bounds of our box, it could be take our character here out of the range of the box, and we're not going to allow that. Okay, so we have to check first to make sure that it's inside the bounds of the box. So to start with, we're going to make two variables that start out the same as our position R and position C. Okay, so these two variables start out just the same as what we already have for position R and position C. And then we're going to get some direction here, and that direction is going to be a character. So we'll say if direction is the character U, right? That's going to be up. So what would it mean to move this up? Well, that's going to be a change in C, or no, that's going to be a change in row, right? So if we move this thing up, this is a certain number row. If we move it up one, then we're going to be changing the row value. We're going to be decreasing it, right? Because it starts out at 0 up here, then 1, then 2, then 3. So this is the row, so we're going to be decreasing the row, which means we're going to have R equals whatever it did before minus the count. So this count that we get from this function is just going to be an integer number. And if it was, for example, if this was U and this was a 1, we would be adding the count. And so actually subtracting the count, right? So to go up by 1, you subtract the row position by 1. To go down by 1, you add 1 to the row position, right? So we could say elif direction, there we go, equals down, then R plus equals count. Elif direction equals left. Then now this time we're going to be talking about the column position. So if we go left, the column position is going to go down by 1. So that means we have to subtract. So C equals whatever it did before minus the count. And then elif direction equals R. Then C is going to equal whatever it did before plus the count. All right. So that's pretty basic. Now what we would have to do is, after we've modified R and C, we need to check to see if R and C are now past the boundaries of our box. So the boundaries of our box is for the row is if it's less than 0. So 0 or more is allowed, and then 1 minus rows or more or less is allowed. So between those two ranges, we have to check to see if R is between those two ranges. And then we also have to do the same thing for column. We see if it's between those two ranges, right? So for this we can do, let's say, so if C is less than 0, or so in the same way, if R is less than 0, that's invalid. The other ways to be invalid is if C is greater than or equal to columns. So that's the maximum number of columns that we can have. So if it's equal to that or greater, that means we've gone past, right? Or I guess columns would be over here. That we would have gone past to the right hand side. And then so, or if R is greater than or equal to rows. Okay, in that case, print unable to move beyond the box. All right, beyond the bounds of the box. All right. So in this case, we did this calculation, but because that would put our character somewhere not visible within our box, we're not actually going to update these variables, right? Now, if none of these items are true, then that means we can update these variables. So this is just an else condition, and we're going to say the position R is equal to R and position C is equal to C. Now we are updating both of these even though depending on the direction we're only going to be modifying one or the other, it's just kind of easier to code it this way. You wouldn't have to update both of these, and in some situations, depending on what you were doing, you might not want to, but it's acceptable for what we're trying to accomplish here. Okay, so we have print box and we have move. So let's test this and see how it works. We've got print box, and then we're going to say move, and we want to move left 2 spaces, and then we have a print box again, and then we want to move up 1 space, and then we'll have to print box again. Okay, so we are in the middle, and we go left 2, and then we go up 1. All right, so that looks like that's working. Now what we want to do is we want to have the user basically specify these commands here, L, U, and this number. All right, so to do this we need some sort of loop. Now since we've made these into functions, this is going to be nice and easy. All right, so we just have our main program here is going to be a loop that runs forever until a certain condition is met, and when that condition is met, we're going to use the break keyword to break out of the loop. Okay? And then once we're out of the loop, we'll say something like program done. Okay, so in the loop, first thing we want to do is print the box. Then we need to get some user data. And we'll say something like, let's see, what do we need to get? We need to enter the direction and then a positive number, right? So and then we'll give a couple little examples here. U5, L4, right 2, down 1, positive number, direction. There we go. All right, and then since this is the input, I'm going to add a colon and then a space. So there's going to be a little space between this message and when I type something in. All right, so we can do that. So once we get that user data, it's basically 2 pieces of information in 1 string that the user types in. So we need to separate that appropriately. So the direction is just going to be the first character on this user data, right? Actually, first, if the user data is empty string, then we break out of the loop. Or something like that. Empty input detected, stopping program, and then we say break. So whenever we counter this, it's just going to break out of the loop, and then we'll go down here and it'll say program done. So, and that's only if user data is the empty string. Right. Now the next thing is, if it's not, then we're expecting the first character to be a direction, and then the remaining characters to be an integer, a positive integer. Okay, so what we can do here is we can say the direction is just that first character of user data. So you can use reference by index here. Square brackets after your string will allow you to reference one of the characters in the string by an index number. So the first one, we know indexing starts at 0, so the first one would be index 0. And then the count, how many positions do we want to move in that direction? That's going to be user data, and we're going to take a slice, and that's going to be from slice 1 to the end. Okay, so slice 0 is on the left-hand side. So imagine we have a string here that's U and then 223 or something like that, even though that's outside the bounds of our box. So the direction is going to be the item at index 0, right? And then user data slice from 1 to the end. Now slices start on the left-hand side. That's slice 0, and then in between the U and the 2 is slice 1. And then if you leave that second part blank after the colon, that means go to the rest, or to the end of the string. All right, so that's going to grab all of these items. So that's our digits. Those are the digits we want to make into an integer, right? But the problem here is this still is a string, right? So we need to convert that into an int. Right? And then we should have a direction and an int. One last thing is we want to make sure this is uppercase. So you can just use the .upper function, and it'll guarantee now that this character is an uppercase character. That's important because we make the comparison in this function using an uppercase character. All right, and then we simply call move direction and then count. Okay, that all looks good. We can run the program now. Enter a direction. So let's try U5. Goes up 5 spaces. Let's go lowercase d1. It goes down 1. Let's go left 44. Unable to move beyond the bounds of the box. That's good. Let's try left 4. That's good. And let's try right 10. Alright. And so that's just a fun little program. And if you press enter, empty input detected, stopping the program. Okay, pretty simple. You do have to keep track of some positions. There's 2 main variables. Because we abstracted the rows and columns away, we could adjust this to whatever we want. I could make this bigger or smaller because I made the initial values of the position of the character in reference to these variables. So really, you can set those to anything. And then we abstracted the print capabilities into its own function, and then the move capabilities into its own function. And so because we did that, the main program is pretty simple. We could take all of this out and make a function called get user data or something like that, and put all of this inside of that get user data function, right? And then our main program would be really simple if we did that, right? But we don't necessarily need to do that. Just as an example, when you abstract away functionality into other functions, right, it makes your code a little bit easier to read, and it makes the main program, the logic flow of it, much easier to understand. Okay, so this is good enough for now. We'll leave it as is, and you can play around with this. Hopefully you learned a little something about simple little toy programs. And while loops, infinite while loops, you can break with the break keyword. So that's all for this video. Have a good one.